at a 5,000 share order.
Hello, everyone, and welcome to another episode of Google Cloud Live. I'm Chelsie Czop, Senior Product Manager at Google. And if you're interested on how AI agents can tackle complex, real-world environmental challenges, then you're in the right place today. We're going to walk you through a brand new multi-agent sustainability intelligence app that's designed to pull in satellite imagery, live sensor telemetry, and dense policy documents and instantly generate a decision-ready risk report for the developers tuning in. We're also going to get totally hands-on. You'll see a Google ADK orchestrator managing specialist agents combined with NVIDIA accelerated GPU inference, Milvus policy retrieval, and also a Cloud Run deployment. So it's all serverless. And I couldn't do this alone. Joining me today is Mitesh Patel from NVIDIA. Mitesh, welcome. Do you want to introduce yourself quick?
Sure. Hi. Thanks, Chelsie. Welcome, everyone. And thanks for having me. My name is Mitesh, and I lead the developer advocate team here at NVIDIA. And the goal of our team is to evangelize different applications that can help developers envision how they can use all these state-of-the-art tools in the work that they're doing. So I'm excited to be here and talk about the sustainability app that we have developed.
Yes, thanks for joining. It wouldn't be the same without you showing us how to do this. And before we dive in, I want to know where everyone's tuning in from today. So drop your city or your country in the chat. And also, what are you currently using agents for, or where are you using agents in production? Would love to be able to hear from you. I'm out of Park City, Utah today, so looking forward to seeing where everybody's listening from. And quick housekeeping note before we get started. If you have any questions during this walkthrough or the presentation, put them right here in the chat and we'll answer them. We have folks behind the scenes here from Google and NVIDIA standing by ready to answer any questions that you have. So with that, I'll get started here. So what are agents enabling? They're enabling cross-platform automation, asynchronous productivity. I know that's where I'm using agents from that standpoint. They're enabling real-world transactions. And the focus of what agents are able to do is that they're optimizing for outcomes instead of just output. So an AI application is a cloud application that contains one or more, or many in the use case that you'll see later, AI agents. An AI agent, so what is an AI agent? It's a service that autonomously reasons to be able to solve a task using tools and data. And like all services, they must meet your compliance requirements, use your CI/CD pipelines, and protect against abusive behavior, traffic, and do so securely across all of your resources. And they must be cost and performance efficient. They need to meet your latency SLOs and elastically scale for capacity for traffic. And, it all has to do that with security. So you need those security guardrails. So that's a lot. Let's look at a concrete example. How can Google Cloud help? So in this example, assume that you need to build an agent to be able to respond to users' requests to generate a new interactive dashboard and be able to surface new insights. So what does that mean the agent needs to do? When the prompt comes in, the AI agent needs to be able to parse the text, build a plan, and then make a series of calls to different endpoints, such as an LLM to generate code, MCP servers to be able to pull that data from the databases or the user. And then finally, they need to coordinate and execute all of these in a useful way back to the user. And when we look at how different components involved in the workflow, we can see how complex the executions can be across the various durations of the executions. So some may be running longer executions of reasoning, other models may be calling multiple MCP servers, and some may have a shorter call to an LLM to generate a simple SQL queries to update a database. Now, with all that complexity, we need to make sure that we choose the best cloud platform that will help us scale for high elasticity, 2, right-size our compute, so that way you get the best cost per performance and you're not paying for what you don't need. And you need to do that while meeting a latency SLO, because if you have to sit and wait, what is the point of having an agent being able to do that in the background? And most importantly, I would say too, is it has to happen securely. You can't have agents going and being broken into or breaking your security guidelines. Okay, so that was a mouthful. Let's kind of get into it and summarize these in 6 key points. Your agentic workloads need to be treated as untrusted. They need to be able to scale and meet bursty traffic, and a lot of them are latency sensitive. Some of them have long-running tasks that are happening in the background, and a lot of them have idle cycles. Finally, some of the more complex ones are usually, those are the hungry ones, especially the memory-hungry ones. So AI agents introduce a lot of unique challenges that can really stress infrastructure and expose the vulnerabilities. So there are 3 categories of challenges that we expect you to see when deploying agents. First is latency and throughput. We need to ensure that applications can scale for elasticity in a world where accelerator capacity is constrained while being able to optimize for that latency. Second is compute efficiency. We need to be smarter about the way that we use the compute to increase efficiency and density and reduce the idle compute resources. And third is security and governance. We also need to apply security controls so that we're empowering agents to be able to handle those long-running controls, complex tasks, all at the same time to ensure that you have control and you have access to it. You can debug them, and you have auditability so that you know and have that governance. So at Google Cloud, we build the AI hypercomputer stack to be able to optimize for all of the AI ML workloads and all the ML life cycle stages. Now it addresses 3 main challenges for AI agents too. It has 3 major layers. At the bottom, my favorite, the purpose-built hardware. You have your open software platform and flexible consumption models. The purpose-built hardware doesn't mean anything if you're not able to use it with your open software and be able to use exactly what you need when and where you need it. So at Google Cloud, we offer a wide range of NVIDIA GPU products, from Hopper to Blackwell to Vera Rubin. And today I'm going to give you a little high-level overview of the G4 product that we launched last year or early this year, which is based on NVIDIA's RTX PRO 6000 Blackwell GPU, because I believe it's a very interesting workload for agentic workloads, as well as it's what Matish's demo is built on today. So Matish is actually going to use in his demo Cloud Run to be able to do it. Now, Cloud Run is a serverless platform that takes all these components that I just talked about in AI hypercomputer and brings them together so that you don't have to use and pick and choose what exactly works for you across the stack. You're able to just kick off a job with Cloud Run, which is why it's so perfect for agentic workloads. So you can use Cloud Run GPU services to perform real-time multimodal inference. Now, in the demo that Matish is going to show, he's going to use Gemma 4 on it, and that has multimodality capabilities. That's how he's able to get sensor data, policy recommendations, as well as real-time telemetry and bring them all together into Gemma 4. Now, for example, say you want to run a chatbot application for your end users if they want to generate images or use the text response prompts. You can use Cloud Run to be able to deploy AI agents to be able to do that. Or say, for example, you want to run an IT support agent or customer service to autonomously answer user questions. Cloud Run GPU services can be used for those non-AI compute intensive resources. So you can use it to kick off media serving, generating images in Gen AI, or being able to use some of those agentic workloads to kick off background tasks. So let's look at a couple design patterns to see how you can use and pull in Cloud Run to be able to support your agents. So here's a design pattern for on-demand inference, AI inference with GPUs. So say a request comes into Cloud CDN and it has your request caching. It would kick off a Cloud Run job via the API. Say it runs an LLM such as Gemma 4. It catches and takes the LLM weights from cloud storage that you've customized, takes it over a VPC with a direct VPC egress, and kicks off a Cloud Run GPU to be able to perform that inference, such as text to text or text to image, and then it sends back the response via the front end. Now, let's look at another design pattern here. Say Cloud Run GPUs are doing LLM fine-tuning and batch inferencing. Fine-tuning Gemma models is a very popular way to specialize them for a special use case or domain. Instead of being able to tune them from a large model from scratch, you can take the pre-trained Gemma models to train them further on a smaller custom data set. This is a lot more efficient and cost-effective as well. Really high level, there's some use cases that are really good for fine-tuning. If you have domain-specific knowledge that you want to bring in, the Gemma models have a broad understanding of the world, but they might lack your industry-specific or your company-specific specialized knowledge in a particular area. So a financial services company could fine-tune Gemma on a data set of SEC filings or market reports or internal company memos. That helps you get the best answers using for your agentic workloads. There's also task-specific behavior or for customer service that you want Gemma, or say you want your agent to be able to do. Say you have a certain set of customer interactions or way that you handle this. That's what it's really good for fine-tuning. Or if you want it to adopt a specific persona or style, you can teach the model to adapt to that tone, personality, or your own writing style. So for example, say an online game developer could use a Gemma model to act as a non-player character, NPC, with a unique personality and speaking style. So there's some fine-tuning techniques. It's typically done using parameter-efficient tuning, so PEFT, unique techniques like LoRA, low-rank adaptation. This method freezes the original model weights and only trains a small number of new lightweight adapter layers. They drastically reduce the memory and compute requirements, and that makes the fine-tuning possible on modest hardware. And pros and cons. So running Cloud Run with GPUs is a great platform for being able to fine-tune the smaller models or performing asynchronous one-off fine-tuning tasks. And you're able to kick off that workload and it can run in the background and you don't have to worry about managing everything. So let's dive in a little bit more about G4 or NVIDIA RTX PRO 6000 GPUs. Compared to the previous generation that we had, the L2 VMs, which is the L4 GPUs, it's 7x more performant, 4x more GPU memory, and 3x most host memory compared to our G2 VM offerings, which was the first GPU that we had with the AMD Turin CPUs supporting NVIDIA's GPU. So G4 is optimized for peer-to-peer multi-GPU workloads. So the benefits that you get from this is that it accelerates multi-GPU workloads. You get 2x the nickel collective performance when you're using the full VM shape or on a 4 GPU VM shape. So there's also fractional GPUs that you could use all the way up to say 4 or 8 GPUs in the full VM. And if you're using the whole VM, then you can get up to 2.2 nickel collective performance gains. All you need to do to be able to get that performance benefit is just turn it on with an environment flag. Now, where do customers use this and where have we seen it successful? Flipkart, one of the largest AI commerce platforms in India, uses it for an AI-led catalog enrichment. So what they do is they take images and they convert it into video. So it's really cool that you can have a first frame, last frame, and it'll generate a video with that output. Now, in the background, it's agents that are kicking it all off, and it's running on G4 GPUs. So what were they able to achieve with that? They were able to use the P2P communication capability with the 2 Blackwell GPUs that they can talk directly to each other without involving that host CPU or system RAM. Now, this gives you higher throughput running video generation models compared to just using it across and running it across PCIe. Now, they found that they were able to get a 50% latency reduction and a 50% cost reduction, which is phenomenal. So they were able to do that with G4 GPUs, which is NVIDIA RTX PRO 6000. And then also they customized their media pipeline and they ensured that the P2P topology design was on. Now, another area where we're seeing agentics really being used, Base 10 shared this at Next, which is really great. There are 3 areas that they really see that agents are being used. And I'm curious, again, put it in the chat where you're using agents, but they're seeing it in real-time voice agents, encoding agents, and research agents. So you're looking at a code base and you're asking it to build a feature. Now it can go and research and understand that code base and give you some developed chain of inference, so chain of thought as to how you're able to do that. And another thing that they said that was their recommendation was to be able to fine tune. That's how you get the best agent productivity. But now let's see it all come together. I'm going to hand it over to Matish to walk you through our sustainability agent app.
Yeah, thanks, Chelsie. But before I dive into this application, it's amazing how Base 10, Flipkart are utilizing agents for various application utilization, and how our Blackwell GPU or the Pro 6000 are helping enable them to accelerate their whole pipeline. And one of the most important things that you talked about in your slide deck is latency is very important, and throughput is very important, and cost effectiveness is also important, because when you're scaling the systems out at production level, cost is the primary factor that drives all this adoption. So it's amazing that that we have it, that all the customers, Flipkart, Base 10 are looking into those KPIs or SLAs when they are designing systems.
100%.
So that's great to see. Yeah.
I'll just share a quick anecdote. I have a friend who started a company and their MVP product didn't take into consideration the agentic kind of demand from that standpoint. And when they started using it, the demand went off the charts, and it wasn't designed in a way that they could sustain the cost for that low latency as well as the low cost efficiency. So they had to pause the MVP, take it back, and then re-architect before they went live. But I'll let you walk through the demo. That's what everybody's here to watch anyways.
Yeah, exactly. So let's dive into it. So what we wanted to showcase here, let's go to the slide deck first. I think I would like to walk them through the... Yes, okay, here we are. So sustainability agent is something that we orchestrated to showcase the effectiveness of various agent toolkit, how we orchestrate this entire use case, because it has got multimodality involved. You're looking at imagery data, you're looking at telemetry data, you're looking at text data. So different modality of data is coming in as input. So you need to design specific agent or sub-agents that can absorb these modalities. And on the modeling side, you need to have a multimodal that is capable to take all this information as an input, this modality of information as input, and then process it and figure out what is the best course answer to that. So with this, that's the reason why we used the climate data as a use case, but this is just one example. There's nothing stopping you from utilizing the same framework or the same orchestration that I'm showcasing here for any application that you're building that involves multimodality and you want to capitalize the capability that Gemma 4 is providing. So how did we orchestrate this agent? So we used Google ADK toolkit. As Chelsie mentioned, we use Google Cloud Run. And then we use Gemma 4 model under the hood. And then for inferencing purposes, we use VLLM engine. There is nothing stopping you from using any other inference engines or backend. It can be SGLang, it can be Dynamo, which comes from NVIDIA based and uses it in production for their customers. And then for vector database, we used Milvus, which is a GPU accelerated vector database. But again, there is nothing stopping you from using any other vector databases that are out there which are GPU accelerated. So, and how did you orchestrate this whole thing together? So at the top, you see the main, the ADK toolkit, that is the main orchestrator. And then underneath, there are 3 sub-agents. Each sub-agent is responsible to take in different modality as an input and then process it and then provide an output. And the main orchestrator will combine all this information coming from 2 or 3 different sub-agents and generate a report for you. So if you, as I said before, we are taking or absorbing multimodal information. So we are taking in satellite imagery as an input. We are taking in telemetry data that is coming in from different weather station information. So we take that as an input as well. And then we are looking at policy documents. And these policy documents can be documents either created by state, or if you tone it down further, it can be policy documents created by different counties or different cities. So for this use case, we looked at a few counties. We collected the PDFs of the policy documents that we had, and we embedded them into vector embeddings offline or a one-time process beforehand. And then at runtime, so when a user or when a decision maker is asking all those questions to the agents, we will go and retrieve the information from those embedded documents and take it out. Let's dive into I would like to show you the real demo of this work. So here is how the UI is orchestrated. So at a higher level, we are using the Gemma 4 31 billion parameter model. We are using a quantized version of it, which is an NVFP4 format. Again, this format came out of NVIDIA, and it is a very good format to use because the model size is quantized quite a bit, and at the same time the effectiveness stays the same, so the quality of output stays the same. So we used the NVFP4 version of Gemma 4. For the embedding side, to embed all the policy documents, we used the embedding Gemma 300 million parameter model. So that embedded all the PDFs or the policy document that we had into vector embeddings. And then for inferencing purposes, for this specific use case, we used VLM as an inference engine, but there is nothing stopping you from using other inference engine, as I mentioned before. And from the input standpoint, we are using satellite imagery, we are using telemetry data, and we are using policy document. So I will reset the platform and hope the demo gods are with us to make sure it runs. All right, so we are using the Phoenix Urban Heat Island Risk dataset, which is satellite imagery. So if you look at the baseline and the current image, so we are trying to see what is the heat risk that we have. We are also using in sensor information and policy documents. So I'll run this analysis. So it dispatched all the information. So the main orchestrator is dividing the tasks to the sub agents out there. So right now we just finished analyzing the satellite imagery. The other sub agent is processing the telemetry. The policy agent is going to go and review all the policy documents and retrieve the right information. And then all the synthesis will happen where all this information is combined together, and we'll get a really good report which states what is the state of the heat risk. So it's reviewing the policy document. Let's hope. Okay, that's done. So it's generating a report now. It's combining all the information that we have, and it's going to give us an output of what it thinks the outcome of combining all this information is. There you are. So it is giving you an executive summary and the recommended next step of what are the immediate mitigation that can be taken care of, or cooling strategies that counties or states can adhere to for them to bring down all the risk factors that this county is facing. So this is just one example, but from an orchestration standpoint, we are looking at a lot of things that we are putting together. And the advantage of using all these toolkits, Google ADK toolkits, as Chelsie, you mentioned initially in the call, it's a handful of things that you need to pipe in together. And Google ADK toolkit is a very good orchestration agent that helps you streamline all these plugging in different sub agents, talking to different retrieval systems. We have not integrated any MCPs for this use case, but there is nothing stopping you from integrating different MCPs as well. A simple example would be we pre-embedded the policy documents. Now, if there is an MCP server available from the state or the county or the city, we can always tape into those MCP servers, and that can be orchestrated as well using the ADK toolkit, or it can be orchestrated offline as well and then plugged into the ADK toolkit. So all this flexibility comes into play at the abstraction layer, because if you try to code it yourself, it's not impossible, but your time to market will just be way longer. And that is where these orchestration toolkit becomes very easy to use. The inference framework becomes very easy to use because they are give or take 3 or 4 click deploy systems in terms of getting the inference engine up and running. How you can orchestrate that, how you can orchestrate agents with ADK toolkit. One last thing I'll add is the way we designed this entire agent platform. It's deployed on Google Run, but we took care of different latency or modalities. And what I mean by that is we made sure that the web app is orchestrated differently than the inference engine and the agent orchestrator. And one of the primary reasons we wanted to do that, or we want to showcase that it's possible to do this on Google Cloud Run, is because when you, let's say you, me, and few other folks from our team are using the same agent, then the concurrency comes into play, and then we want to make sure that the system can be scaled. So all those facilities are available that one can capitalize within Cloud Run, as well as how you're orchestrating your entire framework using Google Agent ADK. So that's the demo I wanted to showcase. But few key messages that I would like developers to take home from this demo is not the climate agent, but the orchestration capability.
Mm-hmm.
Gemma 4 model, multimodality, please take a look at it. It is really, really good. It's open source. As Chelsie mentioned in one of the workflows, you can always download it from Hugging Face. You can post-train it for your use case. It has the ability to absorb multimodality. That's one. The second thing, NVFP4 format. You can always quantize that model further and bring down the model size so it can be deployed on hardware with smaller GPU footprint. And the third thing is the ADK toolkit. It has the ability to orchestrate multiple agent system, which becomes very important for practical use cases. If you're building a demo for yourself, multi-agent might not be the way to go. But if you're building production pipelines, multi-agent will become important. And there are plenty of use cases. Chelsie already mentioned a few of them. There are plenty of use cases out there where multi-agent orchestration is very important.
Great, thank you. So I figured it would be good if we have a little discussion. I was just going to kick off with a simple question, since we both used this acronym a few times, if you can explain it. What is MCP and how is it and why is it so important to agents?
Yeah, so it is a protocol, and the reason why the protocol is designed is it's kind of a rule-based. It's kind of a rule that has been established that you can talk to different servers. So if you are trying to, let's say I'm trying to speak a different language and you're speaking in English, we will not know what each of us are talking about. NCP sets that layer where you can talk to different servers as far as they have orchestrated their entire information and provided access through an MCP. So multiple context protocol, I think there are I'm forgetting it, but context protocol are the last two full forms of the acronyms is my take. But the goal of MCP, yeah, there you go. But the goal is to make sure that if different providers out there want to talk to agent, there has to be an API layer or a call that is streamlined across the board. So all the information providers can orchestrate and make sure they are following the MCP protocol. And all the agent on the other side, they can talk to all these MCPs in the same language. And how this will help the entire ecosystem is eventually you don't have to create different blocks of code to talk to different service providers. If everyone is sitting or using MCP as the protocol, we just use MCP to talk to all of these services, and we don't have to orchestrate different code base or different rules or different API calls to talk to all these providers. That is the most important thing of MCP, that we are streamlining across the ecosystem how you can talk to different service providers.
Oh, fantastic. So it's like the universal USB-C of AI to connect everything.
Kind of, yes, that's the right analogy.
Oversimplifying it there.
Yeah.
So Matish, you work across so many different industries and areas. Where are you seeing agentic AI or agentic really take off for workloads?
Right. So if you think about it, agentic AI started started from the software space, right? So of course, the absorption or adoption is going to be first there. So in for software engineers who are coding or creating different applications, that is where agentic AI is become very, very prevalent. That application space, coding agents is becoming reasonably mature, that you are even reaching a stage where if you are trying to design an application from scratch, there are so many coding agents out there who can help you plan your entire system, create an entire workflow so that it adheres to what you are looking for, and then go and create a baseline for you. So it becomes a very good assistant for the engineer who is coming up with that entire application, and then they can be the decider that I want to orchestrate my architecture this way and not this way. So that is one area where I am seeing a lot of absorption in terms of coding agent. If you go scale it out, take 2 degrees of freedom outside the engineering space, where are the other places where these agents are becoming useful? Healthcare domain. One of Bastian's client is talking about it. My medical doctor, where I go to, they will always take my consent that, is it okay if I record this call so it helps me transcribe? It's like, please go for it. I am the best advocate for that. so that is another place where we are seeing this application. And what I'm seeing lately is a lot of folks who are trying to create different things. A simple example would be you are creating a video content, a video explainer, or you're writing a blog and you want to polish it further. These kinds of agents can become very handy. A simple example would be, let's say I'm writing a blog of how to use Google ADK toolkit and then how to orchestrate that using VLLM. Now I'll get all the technical content. That's easy. But if you're writing a blog out of it and you wrote few bullet points and you want to expand it further or you want to polish your language, these agents can be very useful in that space. And the last place where I'll touch it, which is my personal favorite, physical AI. I'm a roboticist.
Oh, I was going to ask you about that next. I was going to say, you haven't even touched on your background.
Yeah, that's true. Yeah,
Matish has a PhD in robotics. So I was going to ask, where are you seeing it in physical AI?
Yeah, so multiple places. Sorry, I'm going way too fast. but in physical AI space, there are multiple places where you will find applications of agents. The very first place is with physical AI, data generation is very important. How do you figure out what kind of data you already have? What kind of data do you need? And agents can become a very good assistant in figuring out what kind of data you have. And it can be a very good system of generating data as well, because you can hook in your agent with all those synthetic data generators out there, both in form of world foundation model as well as in form of simulation. You can orchestrate agents to go and create those use cases for you. In real world, so this is more on the engineering side when you are understanding your data. If you try to take these systems into production, where you're trying to understand the lay of the land or your environment in which your robots are operating. Let's take manufacturing facility as an example. So in manufacturing facilities, you might see some anomalies. So if you have designed your humanoid or your ground robot to go and monitor those environments, you can simply through an agent ask simple query questions. Can you find places on the manufacturing facilities which should not have chairs? So the robot can maneuver in the environment. It will figure out how to scan the entire environment. It will do its own path planning. But the high-level task you gave, that the robot has to go and scan the environment and figure out if there are anomalies, which is chairs in this case. So the robot can map the whole environment, how it is going to go about in the environment. And whenever it sees an anomaly, it can send a red flag to the control station or the main station where humans are there and say that I saw a chair at this location. Then the user or the human can go in and clean out the environment. But that is another place where these kinds of applications will become handy, and agents will be the main orchestrator or the communicator between the robot as well as the human.
Awesome. And what do you think the biggest challenges are to deploying and using agents in production?
So there are always challenges. These are new technologies, right? So there are always challenges, and I think some of them you walk through in the initial part of your talk. So few challenges that will become very important to address to understand the use case. I think a lot of times we are wasting tokens in terms of generation. So understand your use case very well. This will help you understand what models to use. It will help you understand, once you have figured out what models are the best fit for the use case that you're working on, it will help you what GPU footprint you should use. So while you're orchestrating the entire workflow or your pipeline, from GPU selection to model selection to how you're going to orchestrate your agent, all these decision-making becomes very important when you are evaluating your use case. So understanding your use case very well, what models, this will eventually flow into what GPU footprint or what software stack you need. And then you go into orchestration mode. So the challenge, in my opinion, comes into play is having a good understanding of the use case. And once you are orchestrating all these things into production, the other things, as you pointed out very well in the initial part of your presentation, is guardrails. We don't want agent to produce not safe for work content. So you need to put guardrails in place. So when you're scaling this out in production, all those things becomes very handy. And then elasticity, as Google Cloud Run offers that, you talked about it as well, how you scale up, scale down the system based on the demand that is coming in. So Google Cloud Run offers that as well. So all those things becomes very important in terms of decision-making when you're orchestrating your agent. I think you're on mute, Chelsie. We can't hear you.
You are so right. Another question for you. How do you prevent, in that optimization, how do you prevent agents from becoming stuck in like an infinite thought loop and burning tokens through to make sure that you are efficient in what your token usage is doing and your compute from that standpoint?
Yeah, this is one of my favorite use cases. When you're orchestrating agents, you have one agent that is creating things. In my opinion, you should have an evaluative agent as well, which is evaluating what your first agent is doing. That is the way you can break the loop. If the agent is constantly in some hallucination mode and it is going in a circular fashion and it is not giving the right answer that you care about. So you are burning tokens when the generation is happening, but if humans as evaluator are happening, this is not the right answer, we should change the prompt, right? And we should retest it again. But the evaluator agent will eventually learn where the generator agent is making mistakes. So if you have an evaluator agent orchestrated along with your generator agent, it's like battles of the classic, right? so one is generating, the other one is saying, like, you're wrong, try it this way. And then it generates again, you're right, try it this way, right? So it goes through those things, and that is the way you can break hallucination. That is one aspect. Mm-hmm. The other aspect is, of course, you can put rules or guardrails around if the generation is hallucinating and not good. You'll always have an evaluator along the way, right? So if the generator is not doing the right thing, how long do you want the generator to keep generating? Okay. And there is a new thing that is coming into play a lot, which I'm observing, is routing mechanism. Okay. There is some work done by one of a member on my team of how you can do smart routing. So let's say at the lowest level, where I talked about applications, you have different models. Right now, we only talked about Gemma 4 in the sustainability agent. But let's say you have a club of models. Gemma 4 is there, Gemma 3 is there, Nemotron that comes out of NVIDIA, they are there. We have multiple agent selection capabilities. So you can orchestrate your agent in such a way that you are routing your query to the model which you think is the best model to answer that question.
Oh, fantastic.
So, yeah, if you look at the sub-agent categories, right now all the sub-agents are talking to Gemma, but under that you can orchestrate model selection too. So you can see your agent orchestration can get very complex very fast.
Oh, 100%. It just spawns out.
It spawns out. It exponentially scales out very fast, and you can be fancy. At the same time, you can be efficient as well of how you make your model selection and take the right steps to mitigate the hallucination issue that you talked about.
Okay, so say you're just getting started in this area, and I know a lot of people are probably just hesitant to be able to having a model or an agent in that space to be doing the evaluation and transition from humans to agents, doing those guardrails and checking in. When do you think is a good line or like a baseline that you're ready to make that transition?
Make, make the transition from humans to
Human in the
agents.
loop to agents, kind of monitoring and keeping those safeguards in.
Right. So this question is very well studied in the research world as well. Roboticist, so I know it is studied well there. It is studied well in the other domains as well. One of the places where I see when you can transition from human in the loop to agents in the loop is when agents are reaching human level accuracy. So if the expectation is humans are going to take this decision and the agent is making the same decision, that is the place where you can taper down transition from human in the loop to agents in the loop. The best example is self-driving car, Waymo. It took them 10 years to go into production. That we, at least I'm from the Bay Area, I use it a lot. That we use those services a lot, but it took them a while to take the human out of the equation and let the machine make all those decisions. And I have a feeling that the place where they went from human in the loop to the AI in the loop is when the accuracy or the decision making capabilities reached at the same level as humans. The same analogy can be applied, or when you should take the human observer out of the equation and let agent make those calls for you.
Oh, fantastic. I was just thinking you better pick the right human to do the benchmark. do you want a teenage driver or do you want an F1 driver here? So.
That's true. And there are so many facilities out there where you're not relying on one human, you are relying on collective of human thoughts. You're combining all the thoughts, statistically evaluating it, that if you scale it out from 10 human evaluators to 1,000 human evaluators, is this the right answer? So there are good mechanisms out there to make sure that bias is addressed.
Oh, fantastic. Okay, I'm going to take some questions from our audience, since we said we'd have addressed those questions. So we have one that came in from YouTube. It says, is Gemini Enterprise an option here? I know it comes with agent runtime, but not sure about GPU access. So I'll take that one. There are a lot of different areas of Gemini Enterprise. There's areas where it can deploy and choose the best compute platform, and you don't even have to worry about it. Or there's other areas too where you can kind of customize and say, I know I need this underlying accelerator power to be able to kick things off, and you want to train more in depth there. So there's a lot of different options there where you can even choose the runtime from that standpoint. And keep the questions coming. This is fantastic. Here's a question that came in from LinkedIn. The idea of orchestrating specialist agents with ADK for sustainability intelligence is fascinating. I do agree. I'm curious about the specific challenges faced in ensuring these agents consistently retrieve accurate policy data from Milvus under load. Practical insights on that retrieval layer would be gold. Matish, do you have some gold that we could share with everybody here?
Let's try. I'll share my thought. So one way to do it is the tedious way: humans going in, keeping an eye on how, when the policy documents are updated, you can embed that into the sustainability framework, where you're doing vector embedding of all the documents, and then retrieval will take care of it. That is one path, which is kind of a tedious part, but is the easiest part. And I'll tell you why. A lot of counties have their documentation online, but they have not orchestrated MCPs so that you can access these documents in real time. I think that is the challenge. So till the time all these counties, cities, states don't upgrade their information system and make it easily accessible through MCPs, we will have to go through the manual route. But eventually, these counties will come along in providing access to the documentation through these kinds of protocol. So then you are getting the most up-to-date information. So I think for now, if you are trying to solve something today or tomorrow, the first thing I'll check is, I'll start small. I'll start with the county that I care about, or the state that I care about. Start with the state. If all the documentations are not available through an API call or through an agent, through an API call or through an MCP server, your next thing will break it down, go smaller, go to state or county. Go to county or go to city, and see if there is any availability of accessing those documents through an API call. That is your bottleneck. So if that option is not available for now, you'll have to go through the manual path where these policy documents don't change that often. They do change, but they don't change on an everyday basis, which is good news for us. So you can always orchestrate, embed, let's say first of every month, you do a sweep, get the documentation, embed it. And then you can orchestrate your agent in such a way that it will always tell you when it is retrieving the information, which data dump it is retrieving the information from. So it gives you some human level understanding of whether you can use this information. Is this reliable enough based on some instance that you're trying to rectify? Or you need to go to those servers and try to see if there is a new policy document out there. So that is where you'll have to play with different levels of resolution. Go on a monthly dump, go on a weekly dump, go from state or go to county or go to city.
Oh, fantastic. Thank you. I hope that was some gold that you could take away from that.
I hope so too.
That was the right gold, not fool's gold. No, it was great. Thank you. And Ashutosh had a really good question from LinkedIn as well. I think this came from one of our talking about how the agents can kind of spawn out. A multi-agent multiplies the token bill. And how do you approach that on security, privacy, and regulations on a company-specific data when such orchestration is used?
That's a tough one.
Throw all the tough questions in the invitation.
You are trying to adapt to a lot of rules that are set around, and then you're trying to make sure the answers are in line with what you're expecting, and then you also don't want to burn your token bills, right? I think that is where the challenge comes into play of how efficient you can make your models, how efficient you can make your retrieval system, or how efficient you can make your orchestration. Few things that comes to my mind is the biggest token burn will come from what you're trying to ask and how your model is going through it. So for simple questions, don't reason. You will burn a lot of tokens in reasoning. And you can orchestrate that in some way or the other in your ADK toolkit. We have done that with smart routing. The example that I was talking about, one of my team members has done that, and it is available on GitHub. Try and look into it. So if you do smart routing based on the question, you can also figure out whether you want to keep reasoning or on or reasoning off. That is a place where you can bring in the most efficiency. The other place where you can bring in efficiency is multi-agent orchestration. Multi-model orchestration. But the issue that you will face there is the GPU consumption, because you need to keep this model floated in memory and available for you to address the questions that you're getting or pick the model based on what questions you're getting. So that is another place where I will see if I can bring in some efficiency. But those are the two things that I can think of where efficiency can come into play. And then the sub-agents, multi-agents is a North Star or a dream for a lot of engineers who are orchestrating systems. But at the same time, look at the use case. If multi-agent is not something that you need, if you're only dealing with text and you can get away with images and voice, then look at models that are smaller in size. Gemma 4 has a 2 billion parameter model as well. Way smaller footprint, and try to see if it is doing the job for you. I'm sure the person who's asking this question, he knows these answers already, but I'm just reinforcing your thought that these are the places where if I was you, I will explore of how I can optimize my token burn.
Thank you. I think that's some really good advice. Does anybody online have any softball questions they want to throw at Ratish or me too?
No, keep them coming. It's okay.
Fantastic. I don't see any additional ones right now. So I'm curious. We'll see if there's any more that want to come in. Where are you using agents, like in your personal life? Like, how are you using it for you?
Everywhere.
Everywhere. Okay, now I'm really curious. Enlighten me, please.
Yeah, sure. So I recently orchestrated a lot of skills under the hood, where at NVIDIA we are an email-heavy company. So most of our important communication comes through emails. So you need to keep an eye on emails that are coming in. So I have a sub-brain of myself who will go and analyze all those emails and give me a summary trend. You need to orchestrate orchestrate that these keywords are important, these kinds of use cases are important, these kinds of use cases are important. So you can orchestrate that, and it comes as a news digest every day in the morning. So when I'm on my desk at 8:30 a.m., I go through them, and then I see that these 10 emails are very important for me to address in the first hour, and I'll go back and figure those things out. So that is my email observation. Other places where I have agents orchestrated for myself is there are a lot of great community leaders out there, and they publish a lot. They put a lot of applications, use cases on their GitHub portals. So what I try to do is I have their handles, and I've orchestrated a skill or an agent that can create a news digest for me every day in the morning. And then there are certain GitHubs that I would like to see if there is a code update happen, or if there is a feature that got introduced, and I would like to be the first one testing it or experimenting with. So I have those kinds of agents orchestrated as well, or skills orchestrated within my agent that will go and create that report for me. Like, hey, today in simulation, Mujoko has provided this feature. Mujoko is from GDM, Google DeepMind. So Mujoko has given out, created or submitted this new feature. Would you want to try it, right? So at least I'm keeping myself up to date with the latest and greatest information coming out. Model releases. So I have an agent for that as well, where I follow the top model providers and trying to see if a new one comes out, I'm at least aware of it. So that is where I use agents. And then, of course, for use cases that me and my team members, we work on, because our goal is to create these kinds of applications and showcase it to the developer community so that they can get inspired and build something for themselves, either in production for their company or for themselves. So we do build a lot of those things, and we do use a lot of agents. We reason those things with agents. And very important, one of the person asked, right, the token burn. We are efficient. We don't go and use the biggest model out there. We will have small models deployed on our small memory footprint on our desktops, and we will try to reason with that model. Once we have some information, we'll scale it out to bigger API calls. But token burn, we do take that into consideration. Token doesn't comes free to us either, even though we are at NVIDIA.
That's a good point.
Yeah.
No, I love the inbox summary too. I use that built into Workspace for the top 5 tasks that I need to accomplish. And like yesterday, I needed to return, I got a brand new work desktop here, but I needed to return the old one, and I didn't think the box had been delivered. So it handed me the UPS tracking and everything that I needed to find, or I swear sometimes it takes forever to find that right tab or the presentation that you have. I never show my tabs. That's too much looking into how I work, but finding that right presentation to be able to get a task done, I think sometimes can take a while. So when it pulls those resources that I need to complete the task, that's like the most useful thing that I've found lately.
I totally agree with you. I'm like you as well. I have all my tabs open, and I know some of my team members used to be like, "How do you manage this?" I'm like, "I don't know. I figure out a way." I don't know.
Exactly. Exactly. I know exactly where I left it. Great. I don't see any other questions coming in. But I guess, Matish, I'll just say, how can people get started here? I think we went into some really great ways to optimize your token usage, but if you're just somebody looking into the space and getting started with agents, do you have any advice for them on how they can just kind of kick the tires and start implementing on their own?
That's my favorite question.
Oh, I'm glad I can maybe end on that one, unless somebody else comes up with a better question.
No, I think where I'll start, that is our goal as well. Me and my team, we work on that, evangelizing how we can bring these kinds of use cases and motivate developers. Where we can get started, there is plenty of content out there produced by Google, NVIDIA. There is plenty of content out there. We do a joint creation of content as well. So folks can join the Google Developer Program. Similarly, we have an NVIDIA Developer Program as well. Folks can join that to keep yourself up to date on the latest and greatest coming out. Places where I'll start is if there are community leaders out there who are creating these kinds of use cases, application, content. There's a lot of that available on YouTube. There's a lot of GitHub material available as well. If you open Gemini in your browser and ask, how can I create a simple agent? I'm sure you will get 10 to 15 links, which are really good places to get started. So beyond Google, NVIDIA, we produce content to enable the developer ecosystem. At the same time, there are so many community leaders out there who are producing that content. It depends on which area you are trying to create agents in. So if you're a beginner, there's a lot of content out there. If you are going to intermediate to advanced stages where you are looking at agents for specific use cases, like the Flipkart one that Chelsie, you mentioned, the voice agent one that Based has created, they will have applications or use cases of this very well orchestrated available in form of code that you can use out of the box and try it out first. And then you can go modify it further for the use case that you're working on. So that's my high level view. There's plenty of information out there. If you Gemini it, Google it is an old term now. If you Gemini it, you will get all of that information in your first top 10 links. Pretty easy.
I love you making Gemini it a term. That's great. We're gonna just modify that. Just Google it. I use Gemini for everything. Well, thank you everybody for tuning in. If there is something that was useful, please put it in the comments. I would love to hear what you thought, and that'll help us shape what next week's live stream is going to look like. So appreciate you tuning in. Thanks all for joining. We'll see you soon.
Thank you all. Yep. Hope it was helpful.
I think so.
Thank you. Yeah. Bye-bye.